Hi everyone. Today we'll be discussing nuclear energy, how it's generated, its history, and how it is viewed in the world today. Nuclear energy is generated by placing uranium fuel rods in a reactor core. Neutrons then collide with uranium atoms, causing them to split in a process called nuclear fission. This splitting releases heat, which heats the water that surrounds the core, turning it into steam. This steam spins a turbine connected to a generator, resulting in the generation of electricity. Nuclear energy is a cornerstone in global electricity generation, with more than 400 operational reactors worldwide. 6 nuclear power stations in Canada provide 16.6% of the nation's electricity. The Bruce Generating Station in Ontario is the largest operating nuclear power plant in the world. Despite the efficient energy generation, the Fukushima disaster in 2011 caused a shift in public sentiment towards nuclear energy and has since impacted policy decisions and public acceptance globally. Although nuclear energy is scorned in the eye of the public, its low carbon emissions and minimal land use make it a viable, sustainable power source. For this power supply to be utilized, power plants must prioritize safety measures and ensure up-to-date technology to prevent disasters like Fukushima from happening again.
Here's a brief history behind nuclear energy. The first controlled nuclear reaction was obtained in 1942. Then there was the establishment of the Omnis nuclear power plant in 1954 that proved a promising future for nuclear energy as a reliable and efficient power source. Then there was the oil crisis, which further favored nuclear energy as it was cheap compared to other sources of energy. We saw continued advances in nuclear technology from 1980s to 2000. However, in the late 90s and early 20s, there was a series of unfortunate events that spurred a widespread concern. The 3 Mile Island accident in 1979, followed by the catastrophic Chernobyl disaster in 1986 and the Fukushima incident in 2011. This led to two ethical perspectives. The pro-nuclear believe nuclear is a crucial part of the energy mix to combat climate change. They also believe it's a steady and reliable source of electricity, and if we invest in its technology, the accident should not happen again. They also say that nuclear energy is super energy dense, meaning that nuclear power plants can generate large amounts of electricity for relatively small amounts of fuel. The anti-nuclear point to the catastrophic event like Chernobyl and Fukushima as stark reminder of the potential dangers nuclear power poses to the environment. Anti-nuclear voice argue that creating long-lived waste without a permanent and safe disposal solution is morally untenable. Some argue that investing in nuclear energy diverts resources away from renewable energy sources like wind, solar, and hydro, which would provide safer, cleaner, and more sustainable energy solution in the long term.
Nuclear energy transcends mere power generation. It impacts and shapes our lives in various dimensions. Let's explore some abstract perspective about nuclear energy, touching on its environmental, economic, and social aspects. Firstly, the economical considerations. Economically, nuclear energy influences global markets, job creations, and infrastructure development, presenting both challenges and opportunities for growth. Moreover, it is more economically efficient than other green energy production methods. Secondly, environmental impact. Nuclear energy's environmental impact encompasses various issues like waste management, biodiversity, and long term sustainability. It also offers a better alternative to fossil fuels in terms of gas emissions. Thirdly, social implications. On a social level, nuclear energy sparks debate on safety, equity, and public perception, shaping policies and societal attitudes towards energy production. In contemplating nuclear energy, we confront not just a source of power, but a multi-faced force with far-reaching implications for our world.
Nuclear engineering is an engineering field dedicated to tackling challenges associated with atomic energy and radiation processes. Nuclear engineers use atomic energy across diverse settings, including nuclear power plants, medical facilities, and centers for atomic weapons development. Nuclear engineers engage in researching and developing projects related to nuclear energy, as well as addressing issues pertaining to its release, control, and the management of nuclear waste disposal. Depending on their specialization, nuclear engineers may have varied responsibilities. However, generally the main responsibilities of a nuclear engineer include overseeing the construction, maintenance, and safety protocols of nuclear power plants. Furthermore, nuclear engineers contribute to military efforts by designing nuclear-powered arms and transportation systems. They also work on various governmental projects related to nuclear energy and its applications. Additionally, nuclear engineers are involved in designing medical equipment such as MRI machines.
The next steps we have to take as professional engineers in nuclear energy is advancing reactor technology in both fission and fusion reactions, enhancing safety measures to prevent and avoid any catastrophic accidents from happening, innovating in safe and sustainable nuclear waste management, promoting education and engagement to gain the trust of the people in this technology, and finally, fostering international collaboration in all the steps mentioned previously.